All right. Welcome to another OpenShift Commons briefing. My name is Beverly. Now, this week we have Red Hat's Tushar and Microsoft's Mihaela joining us to discuss big data clusters, which is a new set of capabilities introduced in SQL Server 2019 that allows customers to achieve big data-driven business insights from high-volume big data. It's important to note that BDC requires Linux containers and Kubernetes, and Microsoft now supports OpenShift Container Platform, Azure, Red Hat OpenShift, and Microsoft AKS service in Azure. Tushar and Mihaela will discuss the solution architecture as well as delve into a relevant use case. So you want to stick around for the entire session. Of course, if you have questions, feel free to add them in the chat wherever you're watching this live stream from, and we'll relay them back here. With that, I'll hand it over to our presenters. Tushar.
Thanks, Beverly, and I'm very excited to introduce to you this topic, which is about, as you can see, SQL big data clusters on OpenShift and how it addresses many use cases especially when it comes to data access for everything from analytics to AI and machine learning. So I'm happy to have with me Mihaela Introduction, who is a principal program manager at Microsoft, and she is going to do most of the talking since she's the expert on this topic. So we are excited to have her, and I and Chris and others will monitor the chat. So if you have any questions, please do put them in the chat, and then we can perhaps have some time in the end also to do some verbal Q&A. With that, I'll hand it over to you, Mihaela, and walk us over this exciting topic.
Oh, thank you, Beverly. Thank you, Tushar. And hello, everyone. Thank you for joining today. Again, my name is Mihaela Blanda. I work as a program manager in SQL Server team. I've been in the team for a few years working on SQL Server tools. I've been in Azure, SQL Server on Linux, and then more recently, I started working on SQL Server on containers and then enabling big data clusters capabilities on top of Kubernetes. I'm excited to join the session today. We will start by setting some context with today's landscape when it comes to collecting and using big data. That will later lead to the solutions that we're actually gonna present involving SQL Server big data clusters and OpenShift. Then we will show you how this technology solves some of the challenges organizations face today when it comes to analyzing their data and how they can do this in a scalable and secure way. So we know that today everyone is collecting enormous amounts of data. We've been doing so for a while and at a scale that is growing as well. On one side, a reason that we have more and more data is that there are more efficient ways to store it. And in today's technological landscape, it's pretty cheap to scale against storage like this, and as well as compute, right? Then there is the actual data that exists in various formats and is stored in various locations based on the data type, based on where data is produced, and so on. To take a simple example that we encounter in our day-to-day life, you can think about when you're visiting your favorite restaurant and everything that is happening during that entire visit, from the time you're looking to order until you pay. All kinds of data is collected from personal information, your preferences, and to the maybe the stock price of the producers whose ingredients they're going to use to prepare your meal. Also, with ever-increasing sources of data, organizations need to find solutions to store and analyze multiple and diverse sources of data, and that is stored again in various formats. And there aren't too many enterprises out there that do not have implemented systems, historical tracking systems with BI reporting on top of that, or systems that are collecting signals from all kinds of IoT devices, like sensor data from medical trackers, for example. Departments within the organizations have their own data to store and access. They have data marts they depend on, and so on. So it is more obvious each day that not keeping up with taking advantage of all this technological innovation in the big data space and transform that data into meaningful insights will be a competitive disadvantage. So now you have all this data. You most likely want to use it, extract intelligence, and take business decisions based on that. Here I want to show you just a few examples of some of the most common use cases we encountered with our customer engagements in terms of use cases for analyzing big data. For healthcare, there are multiple use cases that organizations are dealing with, from OLTP resourcing to patient tracking, BI analytics for material resourcing and allocation, data warehousing, and machine learning for revenue projection, and so on. And then there is the length of stay analysis that has obviously a deep advanced analytics aspect to it. And we're actually going to touch on this specific use case a bit more in details later today. And same pattern applies for all the scenarios you see here. There are definitely others, and we put out there at the end a resource where you can find additional references on this topic in our documentation. But building and managing and using an analytics solution is not at all easy. One of the main solution challenges are related, as expected, to data itself. As I've already mentioned, in time and more since Hadoop came into market, as well as in most recent past, the requirements around analyzing a higher volume with an increased velocity of data had a significant boost as well. Then we also have a diverse set of data, relational, non-relational, and other sources that need to be joined in order to be analyzed and extract intelligence out of this joined data set. Next challenge is related to the data access and governance. And as expected, it's very important to comply with internal and external policies when it comes to the data access, as well as provenance. Obviously, in general, governance security is fundamental to any enterprise solution. The third aspect that I want to talk about here is the easy access when it comes to data and the tools required by data engineers, data scientists that need to be reliable and build on reliable resources like compute and storage on any environment, right? In a self-service or maybe on demand or automated way. So based on that, we can define some of the requirements that form these building blocks of an analytical solution. First, a secure infrastructure that is scalable is fundamental from platform perspective. We'll focus a bit more in details when it comes to security today, but I also like to mention the importance of manageability, storage and networking abstractions when it comes to a solid infrastructure. And containers and Kubernetes is at the center of this architecture, offering all these capabilities. They give you the choice of the software you want to run without the infrastructure dependencies, And they also enable easy sharing of the software. They enable automation, versioning, easy portability across various types of infrastructure like physical, virtual, public, and private, and so on. Then you need obviously a solid data platform that you can deploy on top of this infrastructure, and that leverages the platform capabilities in terms of scale. Not only scale, but also the data platform needs to make sure that it enables the right tooling and the right set of functionality to reach out to all the data and easily build intelligent applications on top of that. So when we look at all these requirements and the user expectations from a typical analytics solution, we think that SQL Server Big Data Clusters on top of OpenShift provide a comprehensive set of capabilities that check all these boxes. SQL Server Big Data Cluster is released as a feature of SQL Server 2019. And it extends SQL Server's analytical capabilities that already existed in the product. And it's doing this by adding Apache Spark and HDFS to create a single, secure, and unified data platform. Big Data Clusters applications run exclusively as Linux containers, orchestrated by Kubernetes, and can be deployed on premises or in the cloud. And on the infrastructure side, as mentioned before, Red Hat OpenShift is supported by Big Data Clusters, and it provides this end-to-end commercially distributed infrastructure based on Kubernetes. We recently, early summer actually, we announced support for SQL Server Big Data Clusters deployments on OpenShift on premises, as well as in the public cloud environments with Azure Red Hat OpenShift. This announcement that we made, this effort, is the outcome of a very close partnership between SQL Server team and Red Hat OpenShift teams. We collaborated very well on anything from the design and, more importantly, on the security capabilities that we are going to discuss today in this session. The outcome of all this is that you can now build your analytical applications on top of a fully supported stack using SQL Server Big Data Clusters with deployment best practices as well as enterprise-grade security guidelines that are core to OpenShift. So now let's go through in more details through some process that highlight how actually Big Data Cluster is built on top of OpenShift, and how, I'm going to highlight what are some of the main components that are part of this solution. So first, when you issue a simple create command using a new set of command line tools grouped under what we call AZ data, we first lay out the controller. This component is the management service for the entire Big Data Cluster, and it interacts directly with Kubernetes API and deploys all the other services within Big Data Cluster. One of these services is SQL Server, and you saw it here under the name of the SQL Server master instance, because there are other SQL Server instances in Big Data Clusters. And this instance is it's hosted by the same engine that is available on all the other platforms, on Windows, on Linux, and so on. And it includes all the features and enhancements that were released in the past years for SQL Server with the same performance and security guarantees. This SQL Server can do both analytical and operational workloads. but also has some additional capabilities in case of big data clusters. One example that I like to highlight here is the built-in automated high availability capabilities that don't involve any additional manageability overhead from user side, because everything is built in. Very important, this SQL Server has the same data virtualization capabilities that we released with SQL Server 2019 as when deployed on other platforms, as I said, on Windows, on Linux, outside of BDC. And to go into more details about this use case, it is very likely, as I said, that in addition to data stored within BDC as relational or in Hadoop, some of enterprises have data that might reside in other systems like Oracle, MongoDB, or other HDFS systems in Azure, and so on. By leveraging data virtualization capabilities, you can keep the data in place and secure where it is stored with less maintenance and storage costs, and access all these diverse data sources through SQL Server. And this way, this SQL Server instance becomes like a data hub that reaches out to all the data sources that you have in your data estate. So no data is moved, only the result set every time is returned to the user in a more efficient way, as I said. But when it comes to data scientists, right, and data engineers, their use cases might be a bit different, and they want to run their workloads in a slightly different manner. That's why when you deploy big data clusters, as I said earlier, you're not only deploying SQL Server, but also Spark and HDFS storage, again, as a unit in the same single deployment pattern. So what we call the storage pool includes, as you see here, HDFS. We've also contributed to the HDFS Hadoop project with a concept called HDFS tiering, which allows you to mount other object stores like S3 endpoints, Azure Data Lake Gen 2, and other HDFS-like stores into the internal BDC HDFS as mount points. So then you can essentially cache all this remote data within the storage pool in BDC. So this enables you to easily integrate with already existing data lakes without the need to move all the data in and out in order to get value out of it. Side by side with HDFS, as you can see here in the storage pool, is Apache Spark. We know that Spark Compute Engine enables data engineers, data scientists to mainly process and analyze high volume data in this scalable distributed manner in this memory compute layer. Data engineers and data scientists, they most commonly use Spark for data preparation tasks. They can query data stored in the lake in real time, but they can also, sometimes leverage it for its streaming or definitely for machine learning capabilities. Both for data sources stored within BDC, like I said, in HDFS, in the storage pool, as well as for these remote data sources, what we call external data sources, the SQL Server instance has also this ability to do scale-out queries. And what does that mean is that the compute power of SQL Engine is scaled out when accessing the data in the lake internally. Again, is stored in HDFS or outside through this, what we call compute pool. This is being done transparently at query time and does not necessarily, involve any user interaction, it's all built in with the query, in the intelligence of the query engine in SQL Server. You can also use scaling capabilities to store data in a set of distributed ephemeral tables for query acceleration using the SQL Server instances that are part of what we call the data pool. All these additional layers, like the compute pool, data pool, are there just to enable accelerated query performance when applications are accessing the data stored in the lake. So to summarize, you can query your data lake in real time with SQL, but also with Spark. You can ingest streams of data with Spark streaming. You can do training of machine learning models using Spark ML, but you can also build and consume models into the database with SQL machine learning services. Again, SQL Server master instance have the same capabilities as any other SQL Server deployed on other platforms. So when I talk to about machine learning, this is where the application pool is coming into the picture. And how is it used? It's you can basically deploy these machine learning models, operationalize them, and expose them through simple REST APIs that a business application can easily call. And everything, the advantage of this application pool that everything is happening in the same security boundaries of big data clusters, and it's side by side with where the data resides. So let's go through a simple example that better illustrates the use case for all of these components in the big data cluster. We are going to look at the healthcare use case, the length of stay. Just to give you a definition of what length of stay is, as you know, in order for hospitals to optimize resource allocation, it is very important for them to predict, to be able to predict how long a newly admitted patient will stay in the hospital. And so advanced length of stay prediction at the time of admission can help hospitals to enhance the quality of care, to improve efficiency, help with accurate planning for discharges, as well as reduce costs, right? So what happens is that first the hospital's IT department will acquire and set up the OpenShift infrastructure. They will ensure a consistent and reliable system that is easy to deploy, and again, it's secure. Then with this simple easy data command, the IT department deploys BDC to meet their business and operational analytical needs. And to continue with our example, the hospital administrator will want to see certain types of reports that require access to the patient records. And the data for this report is available for them from SQL Server. And they can easily visualize this data using some predefined set of reports in their application using Power BI or any other reporting tool. For another use case, the data scientist this time will create a data model to be able to make predictions based on the available patient data. This time the data is stored in the storage pool, and it needs to be joined with data that is stored in SQL Server. They can do this either by using SQL Server master instance. Again, they can leverage the embedded machine learning services that are in SQL Server with R or Python, or they can use Spark this time if they are more familiar with the technology, or for a targeted use case like data preparation, for example. Data scientists, data preparation, the model training and evaluation from Azure Data Studio, which is de facto tool for managing and interacting with SQL Server big data clusters services, or they can use their any other IDE for doing so. And when done, their code is again operationalized, deployed in an app. These applications are deployed side by side with the data in the same security boundary within the application pool in BDC, and exposed through a REST API. And how this REST API is used. Let's take the example of a medical provider. Let's assume that it's one of the department head nurses, and they are using a patient tracking application that is underneath the covers, is querying this REST API and see the results of length of stay to better plan for the resources or personnel required in the upcoming days. So moving further from the example earlier, managing all these services that enable you to run relational and big data workloads in this secure, efficient, and scalable way is not at all an easy task. But with big data cluster, you can operationalize the management and the data engineering tasks in an integrated and consistent way within this container-based architecture that is more modern and built on top of OpenShift. If you are trying to deploy big data clusters, you will most likely notice it deploys pretty quickly. You can have a big data cluster up in a matter of a few minutes. Also, one of the promise of containers is that all the software required is self-contained inside those images that are being pulled during the deployment. So once the big data cluster deployment completes, you don't need to install additional software to run your SQL Server or Spark workloads or to manage the system itself. Then it is easy and fast to upgrade as you go along. We release new versions of the software of those images pretty much every month. And in order to upgrade, you can simply trigger an upgrade command using the AZ Data Big Data Cluster tools. And this controller component that is running inside the Big Data Cluster will orchestrate a rolling upgrade of the software throughout the entire cluster. In the same time, this container-based architecture model ensures a predictable, self-contained, and fast deployment workflow, as I said, and that's regardless of the targeted platform. Whether it is on premises, on your own hardware, or it's running somewhere in the cloud, you pretty much get the same and consistent experience. All these built-in management features are available in the big data clusters, lead to a self-managed and a pretty much autonomous platform that enable you to focus on the application and getting valuable business insight out of your data rather than focusing on the management part. So with the recently announced support for OpenShift, the BDC deployment model and the experiences were enhanced to be able to deploy big data clusters on this new platform in an integrated manner. So for example, if you are going to deploy big data cluster on OpenShift, you're gonna see that we added in the product itself a set of templates that are targeting the OpenShift environment with specific defaults. And both from BDC as well as from OpenShift side, we provided these tools and or APIs, as well as the command line utilities or even UX experience that make it easier for you to manage things around this infrastructure. So when it comes to, we talked about management, when it comes to administration, we know that for years, SQL Server commitment was to support this mission critical applications from a security perspective, high availability, automated upgrade operations, as well as monitoring and troubleshooting. Active Directory authentication, it was one of the primary requirements from our customers when it came to security around big data clusters, and it is available for secure authentication. And it provides an integrated security model that spans all services, including SQL Server, Apache Spark, as well as HDFS. One thing that I would like to highlight here when it comes to security is that we've enhanced the security design of BDC, specifically to take full advantage of the OpenShift Container Platform. And one of the most important enhancements in this regard is that now containers that are running within the BDC are running as non-root users as a default configuration when you deploy the cluster. For an in-depth detailed analysis of this security design, we jointly published a white paper. It was co-authored by SQL Server and Red Hat security teams. And again, I put it in the resource section, as well as you can find it in our documentation. And it's very important to go through that as it describes the design in details. It's highlighting what and why we require certain security policies when deploying BDC on OpenShift. BDC also deploys additional components to manage high availability, as I said earlier, as well as management and monitoring components. So each and every container inside BDC has this sidecar monitoring container that takes the logs in Elasticsearch and the monitoring telemetry into an InfluxDB database. So you can later visualize these metrics and logs through Grafana, as well as Kibana dashboards that are provided and deployed by default within the cluster as well. So to show you some of these capabilities, I'll now run through a BDC demo that shows how it integrates with OpenShift, both from manageability as well as from security perspective. We're going to go through an end-to-end deployment workflow, and we'll also showcase how simple it is to upgrade the process, to go through an upgrade process of this system in the end of the demo. So for the demo, I'm using Azure OpenShift cluster, and this particular one has 4 worker nodes. And as the next step, I'm gonna take care of setting up the prerequisites for deploying BDC. First, I'm gonna take care of the setting up the security context. So we'll create a custom one for the namespace that we're gonna deploy BDC in. As you know, these SECs are groups of security-related configurations for deployments on OpenShift that support secure enterprise deployments for various use cases. Oh, sorry, it started over. Sorry, I touched the. Yeah, so again, going back, we're gonna deploy the SEC, and this custom security context that we're gonna deploy for BDC is based on the non-root built-in security context that is coming with by default with OpenShift, but we customize it with some additional permissions that are required for BDC specifically. As I said, you can refer to our documentation or the security white paper that we published for an in-depth details of the security integration and an explanation of why these additional capabilities are required. Once we have our custom security context created, so let's see if it shows up in the SEC list. We will create a namespace that BDC is going to be deployed in. So the step is creating the custom security context, and then we're going to see it in the list. BDC SEC, and as I said, we create a namespace. And to complete the security prerequisites, we must bind this service, this namespace with the SEC and this account used by various BDC application for the above create namespace only. So this way, the namespace becomes the security boundary for BDC users. The next step is to choose what configuration templates to use as baseline for your deployment. And as I mentioned earlier, for a tighter integration with OpenShift, we included deployment templates with appropriate defaults for the OpenShift platform. So you see here the OpenShift one as well as the Azure Red Hat OpenShift. In my case here, I'm going to use the Arrow Dev Test one. And the neat thing about this built-in profile is that all the defaults make sense for a test environment, and everything is pretty much ready to go. I don't have to change much, but just the name of the cluster, since I have to match it with the namespace I created earlier. But if other edits are necessary to update, like if you want to customize storage or the scaling of various components, or if you want to customize service-specific configurations, you can either use the AZData command tool as well as your favorite AD tool like VS Code to make any other customization. Before starting the actual deployment, we must not forget to set the credentials, right, to access the external endpoints in the cluster, like SQL Server or the Knox gateway to access HDFS, and so on. So we issue the BDC create command, and from this point on, we are hands off. All the BDC components are laid out, starting with the controller. And once the central management service of the cluster is up, it will take the responsibility of coordinating with the Kubernetes API service the deployment of all the other BDC applications, check their status, and so on. For a deployment of this size, the default size, it should not take more than 10 minutes to deploy, and even faster if you pre-pull the Docker images from the repo. So now that deployment is done, you can log into the controller service to find, for example, the connectivity information for all the other endpoints in the cluster, like SQL Server, Spark, the monitoring services, and so on. So this endpoint list command is giving me the information about all the endpoints that are available in the. Another quick example, as I said, I want to show you how to leverage the power of containers and the orchestration with Kubernetes and OpenShift in this case during an upgrade. You can simply trigger the upgrade using the AZData tool. It's pretty straightforward. You just specify the target repo as well as the image tag that you want to use to upgrade to, and then this controller running inside the big data cluster will orchestrate a rolling upgrade of the software throughout the entire cluster. Again, it takes care of the service dependencies. It does it in a specific order. It checks the service health. It rolls back automatically if necessary, like if it encounters a failure, it will roll back so you can fix that and reissue the upgrade and so on. Again, a hands-off and pretty fast and neat experience as well. So this pretty much sums up what I wanted to share with you today. I hope it was useful. I am putting here some other resources that we made available for you at the announcement time, and then we constantly enhance our documentation and articles on with more use cases and examples and details on the architecture and so on. So check out this latest SQL Server blogs as well as the BDC documentation to learn about the improvements that are being released each month. And for what's next, right? We are continuing our collaboration with the Red Hat as well as OpenShift. We are planning to close the gap we currently have regarding the software stack. Right now, the Docker images are based on Ubuntu, but we're very, very close to have UBI-based images for all the Docker images that are required for BDC deployments. We are also working with our partners on various reference architectures for BDC, and some of them, like HPE and Dell, you can actually have the links there, already published reference architectures that showcase how to scale BDC and leverage OpenShift on their specific hardware. We are still working with a lot of customers and supporting them to build their solutions. Some of them are just working on POCs, others are more advanced with their implementation, and we are working with them to eventually be able to share their use cases publicly in the future. Thank you again, and I'm gonna hand it over to Tushar if you want to add something, or if there are any questions that I can help with, I can.
Yeah, thank you, Mihaela. This was very good. I mean, just to reiterate, we are very excited about that, about this solution, working with Microsoft. We have, as Mihaela mentioned, we have several joint customers. One of them is that I recall is a bank, and their big challenge really was their goal really was to build, to better build a solution that gives faster speed to market for newly launched products for the internal and external customers, and their data was kind of across multiple internal Hadoop clusters, and they also wanted to do more customer acquisition and retention, do more comprehensive central marketing reporting, and this overall improve customer experience. Kind of no different than what other companies are trying to use AI, machine learning, and analytics for in general. And the biggest issue that they have, and you all might find yourself in, is the idea that these bespoke solutions, doing it yourself, are difficult. It takes several weeks, and then they're very hard to debug. So when finally when we introduced them to this BDC solution on OpenShift, they were able to complete that from design to implementation in a matter of a few weeks, and now it's a stable solution within that bank. So they were able to, so the solution itself is comprised of BDC with Apache Spark and HDFS, and all running on top of OpenShift. So so this is very exciting for us. Continue to, as Mihaela said, we have several other prospects and we have several other customers on this journey already, so we'll try to bring those case studies also as we go along. And that's it. There were a couple of questions, Chris. I can tee them up. I think one really was about the idea that if you have data in NFS, like for example, somebody had a question saying that what if I have unstructured data such as MRI and X-ray data in a external NFS? How would you bring that? How do you access that using this solution? Mihaela, what I said really was that you can basically use things like Kafka, even Spark to ingest that data into the BDC. But
that's pretty much the common pattern that we see customers doing, and we recommend. So you stream that data into BDC, and then you can access it either from Spark side or SQL Server side and analyze it. Yeah, that makes sense.
Yeah. So the other question really was, has this all been containerized? And the short answer to that is yes. But if you want, I think you kind of went over that a little bit during the presentation. But
yes. All the components that we talked about from the application side as well as from management side, like SQL Server, Spark, HDFS, and from management side, like all this controller related services, the monitoring with the Elasticsearch, Kibana, and so on, and the dashboards, everything is running in containers and on top of Kubernetes like infrastructure. It's 100%, and it's only available in containers.
Cool. At least those are the two questions I can see. Chris, do you see any additional questions that you want to tee up? Chris doesn't have any. So if there are no more questions, then I think thank you very much, Mihaela. I'll hand it back to Beverly, and then I think we can conclude.
Yeah, thank you so much, Mihaela. Thank you, Tushar. Big data, I'm sure it's a hot topic right now. And like you said in the roadmap, there's going to be a lot of use cases coming up. So this was very great and timely. It was a very great and timely presentation. So thank you once again. Also a huge shout out to Chris as well for producing this session and making the live stream very seamless. Thank you all for watching, and thanks for the engagement as well. So I guess we'll wrap it up now. Everybody have a great rest of your day. Bye.
Thank you. Bye.